Come on. Okay, we're live. Good. That's what I want to see. So, definition of polynomials. What is a polynomial? So it's any expression. So it's an expression with whole number exponents. And if you don't know what a whole number is, those are the numbers 0, 1, 2, 3, 4, ... So a whole number isn't a fraction or a decimal or a negative. A whole number is just 0 through, go up to infinity, but it's just the counting numbers, right? That's it. No decimals, no fractions, okay? So, as an example, if you had 3x squared plus 2x, 3x cubed plus 2x plus 6x, that is a polynomial. But if you had something like this, if we had like a, like a 3 over x plus the square root of x, that is not. That is not. Because that's an x to the negative 1 when you bring it up. And then x to a 1/2 power. So that is not. That'd be a negative 1 when you bring it up. X to the negative 1 plus an x to the 1/2 power. So that's not. Okay? Now, polynomials have names, and it has to do with the number of terms. Okay? Terms. So if it has only one term, it's called a monomial. One term. Okay? If it has two terms, it's called a binomial. This is a trinomial. Okay, 1, 2, 3 terms. So if it has 3 terms, it's a trinomial. 3 terms. So when we're factoring, we'll say, let's factor this trinomial. I know I've said that lots of times. I'll say, let's factor this trinomial. We're talking about 3 terms, right? Now, beyond that, quadnomial, pentanomial, sexanomial, oh, that sounds terrible. I mean, hexanomial, oh, that sounds bad too. Septanomial. Yeah, I mean, yeah, you can go to undenomial, dodecanomial, but that's just crazy. So anything more than 3, we just call a polynomial. More than 3 is a polynomial. Is more than 3 terms, okay? So if you've got 4 terms, just call it a polynomial. Don't call it a quadrinomial. That's silly. It's got 5 terms. Don't call it a pentanomial, quintinomial, whatever, right? Just call it a polynomial, okay? Standard form, we just want the biggest degree first. So what is the degree of polynomial? Well, the degree of the polynomial is the biggest exponent. So in this example, up here, this one's degree 3. Biggest exponent. It's that easy. Now the problem is sometimes we write them in the wrong order. So standard form really is biggest exponent down to the smallest. Okay? So as an example, I'll squeeze one in here. Let's say I've got a 4x minus a 3y squared plus a y cubed, okay? Here's my example. I'll highlight it so you guys can see it. I'm getting kind of squished up in here. That is not in order, not in standard form. Even though the 4 is the biggest number, that doesn't matter. It's the exponents. That's the biggest, so you rewrite it. That one goes first. Y cubed, then minus 3y squared, then 4x, okay? So we call it descending order. Descending order. Biggest exponent all the way down, okay? And the degree of this one would be degree 3, okay? Now, once you write it in order, the leading coefficient, who's leading the charge? Who's in front? Well, the number in front. In this case, the leading coefficient's 1. Okay? It's just the number in front. It's just, that's all it is the number in the front. Okay? And it's an important number to know because it tells us about end behavior. Okay? So, I don't know what this graph looks like, but I do know it's going to shoot off at the end to infinity because the leading coefficient is positive, okay? Now the roots or zeros. Am I going too fast? Okay. The roots are 0. Are really like x-intercepts, okay? Or it's any number that makes p of x equal to 0. I'll show you an example. Let's say I've got p of x equals x squared plus 4. Hold on, I'm going to show you. I want to show you something. Hold on, let me get a better window. There it is. So you could say there are no zeros. You could, right? You could say there's no zeros. It doesn't never cross the x-axis. But I'm going to say that 2i and negative 2i are, and this is why you get this term roots, because if I were to plug in 2i, I would get 0. Plug in negative 2i, I would get 0 also. Even though they're not x-intercepts, they're still going to be zeros, okay? Okay, I'm going to show you something. I know, and some of you might get mad at me. Just forgive me. Yes, these calculus, of course, have an I button. Didn't show you that, did I? Of course they have an I button, right? Isn't that sweet? Of course they have an I button. So 2i squared plus 4 is 0. So therefore, there are imaginary answers that are roots or zeros, okay? All right, example 1. Let's do this. Okay, give yourself I'll give you 2 minutes. Okay, rewrite it in order, okay? You can do it. Rewrite it in order, in standard form. And then tell me what the degree is, and then tell me what the leading coefficient is. You can do this. I have faith in you. Thumbs up? Everybody agree with that? Okay. What's the degree? What's the degree? Yeah, Evie? Everybody agree? Degree is 4. Good job. What's the leading coefficient, Miles?
3.
There you go. Awesome. Now, P of 2. What does P of 2 mean? Yeah, just plug in 2. So I'm going to go P of 2 is equal to a 3 times a 2 to the 4th power minus 7 times a 2 to the 3rd power, 5 times a 2 to the 2nd power plus 9 times 2 plus 10, right? I'm just going to use my calculator because that's just the way I like to do it. I mean, that's too much work. That's just too much work. 3, 2 to the 3rd power minus 7 times 2 cubed. Oop, I have a mistake, don't I? 4. I have a mistake. 2 power minus 5 times 2 squared plus 9 times 2 plus 10, and I can answer it. Oh, I got a 0. Oh, that's kind of cool. So that means that it would be a root, right? So P of 2 is equal to 0, okay? Which means that 2, x equals 2, is a root. That's a root. A root. Because you got an answer of 0, okay? Or it's a 0. We're going to call it a root, okay? Because we're in pre-calculus now. There's a reason we call it a root, okay? So how about P of negative 3? Okay, if you want to grab a fancy calculator real quickly, grab one of my fancy calculators. You're going to appreciate that, okay? P of negative 3i is going to be a 3 times a negative 3i to the 4th minus 7 times a negative 3i cubed minus 5 times a negative 3i squared plus 9 times a negative 3i plus 10, right? And, you know, we don't use my calculators very often, but they're pretty handy. Don't go buy one, because you can always borrow mine, right? And then you have an I button, which is really cool. So you really do have an I button. It's down by the period, by the decimal. Do you see it? So if I go 3 parentheses and I go negative 3 and I push my I to the 4th power, okay, right? And then I'm going to go minus 7, and I'm going to go a negative 3 I to the 3rd, and then minus 5 times a negative 3, and I'm going to plug in my I squared plus 9, and I'm going to plug in my negative 3 I, and then plus 10, right? And then, boom, that's my answer. So what's cool is my calculator actually gave me an answer in terms of I. I know I didn't show you that button on purpose because I wanted you to do I without the calculator on the first test, right? So I get an answer of real plus imaginary. It is 298 minus 216i. Okay, that is not a root. Not a root, okay? Okay, so 3i is not a root because I did not get 0. Does that make sense? You got to get 0 for it to be a root, okay? How am I doing? Am I going too fast? Ryder, do you want me to wait for you? You got it, Jack? Did you get it? Isn't that a nice button, the I button? Yeah. And probably you could find that somewhere online, I'm sure. Okay. Example 2. Okay, this is easy. It is easy. Find the zeros. Well, set it equal 0. Zeros, set it equal to 0. All right, so now here's what some kids do. And don't do this. Here's what some kids do, but don't do this. They start multiplying it out. It's already factored. Remember how we factor and get many equations? That first step's already been done for you. We already have our many equations, right? So we just want to know when is 3x equal to 0. We want to know when 2x minus 1 is equal to 0. And we want to know when 3x plus 5 is equal to 0. And we'll find the x values that make it 0, okay? Divide by 3, x equals 0. Plus 1, divide by 2, I get 1/2, right? And Malachi, you can always take a picture of my notes if you miss out on all of it, okay?
Thank you.
Minus 3, divide, oh, I'm sorry, minus 5, divide by 3. Okay, those are my zeros, okay? Has 3 zeros. Okay, easy. But now number 3, example 3, is not factored. We need to factor this one so it looks like this. We need to make our mini equations. We need to take this example and make it look like this. We're going to factor, okay? Well, let's see if we remember how to factor. Anybody see the first step on this, on example 3? Yes, Jack, what do you do?
Take out the common get common factor of x.
Nice job. Common factor out an x. X squared minus 2x minus 8. Awesome. Totally agree. Yep, yep. Okay, so we've got one answer. We've got 1, 0. Factor again. Factor again. So, you guys know how to factor that. I know you do. Come on, shout it out. What's that one factoring to? Yep, yep. So, x plus 4, x minus 2. Whoops, I got it backwards. You're right, Cameron. You said it right and I wrote it wrong. There you go. Minus 4 plus 2. Thank you, Cameron. And then mini equations, right? Right? And then one answer is x equals 0, x equals 4, and x equals negative 2. Okay? Thumbs up? Okay. Now, this could be a graph that looks like this. I know how this graph looks. I know it has to look like this. You can put it on your calculator, but I can graph it. I don't know the y values, but I know it has to look like that. Because here's my zeros. And my leading coefficient is 1, so I know it's got to take off to infinity at the end. Right? Math doesn't have to be hard. Just it actually makes sense. Okay, example 4. Right? Set it equals 0. It says 4 answers. How am I going to get 4 answers? Four answers. Okay, anybody have any brilliant ideas what we're going to do first? You could do that, or fourth root, right? And if you fourth root 81, you'll get 3. And that's good. That's one of the answers. Or negative 3, right? I'm going to factor. Cameron, you're totally correct. You'll get 2 of the answers. I'm going to factor instead, okay? Because then I think you guys are going to see the other 2. Plus 9 minus 9, okay? So Cameron, this part right here is going to give you your answers. Okay, and I'll show you how, okay? That's going to be a 0 equals an x squared minus 9, right? Plus 9 plus 9. Here's what you said. You said square root, right? So square root of 9 plus or minus square root of 9. So plus or minus 3. So I've got 2 answers. Good job, Cameron. There's 2, right? Everybody see that? However, there's 2 more. So let's take a look at this part of the equation and do the same thing. 0 equals x squared plus 9, right? And let's solve it the same way. Minus 9, negative 9 equals x squared. Negative 9. You think I said that loud enough? Negative 9, because when I square root, what's going to happen? I'm going to get 3i. But remember, 2 answers, so plus or minus 3i. So I did get 4 answers, didn't I? I've got 2 imaginaries and 2 reals, but I still got, you ready? I still got 4 answers. I got 4 answers right. I got 1, 2, 3, 4. 2 of them are imaginary and 2 of them are real. Okay? How's that sound? And then an example of this graph, because we're seeing, looks something like this. So what happens is this. Right here, the graph never comes up and crosses, correct? And that's where you get your 2 imaginaries right here. You have to imagine, okay, you have to imagine that they go through and come back, but they don't, right?
Really weird when you put it in Desmos, just to figure flattens out.
Oh, yeah, but look at your y-axis. Squish your y-axis. Isn't your y-axis like to the hundreds or something like that?
I haven't zoomed out really close so I can see this.
Right, but I think your y-axis...
Still